Welcome to Land Administration S'mores, where complex land issues meet campfire clarity. My name is Jack McKenna. I'm a geospatial consultant and land administration subject matter expert. We break down land rights, cadastral systems, geospatial tools, human rights, and property law into digestible bites, just like s'mores. From boundary disputes to land grabs, titling systems to tenure security, we're here to inform, ignite debate, and inspire change. Whether you're a professional, an academic, a student, a policymaker, or simply land curious, grab a virtual marshmallow and join the conversation. Today's presentation is drone camera calibration, why calibration still matters in the age of PPK and AI, and where the no GCP hoax is debunked. The ASPRS presentation report. This report is based on an ASPRS monthly meeting presentation delivered by Michael Detwiler on UAS boresighting and calibration on May 29, 2026. It was prepared to help promote awareness of ASPRS UAS standards and to provide technical clarification regarding UAS boresight calibration, camera calibration, and related accuracy considerations. It also addresses claims and practices within the UAS industry that may be inconsistent with established ASPRS standards and accepted photogrammetric principles. Individuals seeking clarification regarding UAS boresighting, calibration, or ASPRS standards are encouraged to contact Michael Detwiler, whose contact information is below. This is Jack McKenna with Land Data Plus. The views expressed in this report are those of the presenter, not necessarily ASPRS or Michael Detwiler. About Michael Detwiler and ASPRS standards. As the owner of Great Basin Geomatics and an assistant director of the ASPRS UAS division, Michael Detwiler is a strong advocate for standards-based UAS mapping practices. He promotes the rigorous calibration, quality control, and accuracy verification principles that have long formed the foundation of professional photogrammetry and ASPRS standards. Through his professional practice, presentations, and leadership within ASPRS, Michael continues to champion scientifically defensible, standards-compliant mapping methodologies that prioritize accuracy, measurement, assurance, and professional responsibility. Presentation content. It's a history of calibrating analog and digital cameras. Enter the drones and their cameras into the arena. Boresight procedure, processing steps, pros and cons, and further reading. The history of the United States Geological Survey and camera calibration. Analog film cameras from the 1950s to 1970s. The USGS Optical Science Laboratory, established in Reston, Virginia, operated from 1973 to 2017. 1992 began calibrating digital cameras. USGS would calibrate your large format film camera annually. Periodically or seasonally, a boresight calibration could be performed, as changing seasonal temperatures affect components differently, and the installation or de-installation into different aircraft. ASPRS camera calibration panel. USGS requested help to standardize digital camera calibration. It was formed in 1998 to 1999. The USGS announced the end of calibrations around 2000. ASPRS intervention extended support through 2007. Calibrations are now performed by manufacturers. Camera boresight calibration. It's an alignment of the optical axis with IMU/GNSS to calculate pitch, roll, and yaw offsets. Boresight calibration bridges the gap between the camera's frame of reference and the overarching system's coordinate frame, for example, the drone or the aircraft. The problem: even a fraction of a degree in misalignment can translate to large targeting errors or skewed georeferencing on the ground. The solution: by comparing the expected orientation of the camera with empirical sensor data, or by observing known physical targets, GCPs, software algorithms calculate the precise misalignment and generate Boresight angles that apply corrections to future data collection. Drones and cameras. There's no more calibration lab. In the rise of drone mapping technology, off-the-shelf cameras become standard. Improved quality, but both non-metric and metric cameras are available. Metric versus non-metric cameras. Metric cameras have known geometry. Non-metric cameras rely on software calibration. Non-metric versus metric. There's the GeoQ Loki, external GNSS antenna, external data logger, lab calibrated Zenmuse X4S camera, and the Phantom 4 Inspire Matric 210. Post-process kinematic PPK. The benefits of PPK: improves image geolocation accuracy, reduces GNSS positioning errors, improves aerial triangulation stability. It may reduce, not eliminate, the number of required ground control points, improves efficiency in large or remote project areas. PPK and the no GCP hoax. High accuracy mapping requires both PPK and calibration. No GCPs is a hoax that not even a white paper can disguise, and ASPRS standards have put that hoax to rest. Calibration site: 5 to 10 acres, mix of features, minimal trees and vegetation, avoid homogeneous surfaces, have a building with 2 or more floors, a minimum of 5 GCPs, and a minimum of 30 photo-identifiable checkpoints. Calibration flight plan: 1 iteration. West-east lines, 300 feet above ground level, 70% side lap, 70% end lap, and nadir imagery. Calibration flight plan: another iteration. Diagonal flight lines, 400 feet above ground level, 70% side lap, 70% end lap, oblique imagery by 30 degrees, no horizon visible. Lab office calibration. Example, Angisoft office calibration workflow, checkerboard pattern calibration, software-based camera calibration. Pros and cons. Flight calibration replicates the mapping mission. Office calibration is easier. Is it better? Processing. Import images. Loosen PPK geotag constraints if necessary. Process initial aero triangulation. Review QA report, initial versus optimized values. Input ground control points. Constrain aero triangulation to known values. Verify checkpoint accuracy. Differences should be minimal, within approximately half a millimeter. Processing 2. PPK geotags improve after calibration. You get better XYZ constraints. Compare calibrated and uncalibrated values. Large format example, the Vexcel Ultracam Eagle M3. Conclusions: less distortion, less XYZ drift, reduced processing time. Further reading: USGS camera calibration, ASPRS calibration report, UAS calibration guidelines. Key takeaways from UAS boresighting and camera calibration. Camera calibration remains essential to measurement assurance. Boresight calibration improves georeferencing accuracy. PPK and calibration work together. Ground control and checkpoints remain important, vital. Calibration reduces distortion and improves efficiency. ASPRS standards provide the framework for defensible mapping. Thank you for watching Drone Camera Calibration and the new GCP hoax that has been debunked by ASPRS.